Hi dear friends, welcome to the next part of integration. Well, as we already started with definite integral and we have solved a couple of problems on the definite integral. Now, in today's session, we're going to start with a very important concept of definite integral with respect to boards as well as competitive exam perspective, because one question in board exam of 6 mark will come from this properties of definite integral. Well, when I say properties, you might have remembered that in the chapter number 3 or 4, I guess, determinants, where we have seen some of the properties of the determinants. So why do we have those properties in the determinant chapter? Well, properties will help us to solve the problems easily. As you already know, by using some of the properties of determinants, without actually expanding the determinant, we have found the values and we have written the values, isn't it? So similarly, in integrals, particularly in definite integral, if we have a complicated problems, then those problems can be solved easily if we know the properties. So today we are going to see I think there are 7 to 8 properties are there, and we are going to see all those 8 properties, and based on those properties we are going to solve problems so that it will help you in the exam. Okay? Well, so when I say properties, so let's start with first property, and we call it as P naught property number 0, they actually call it. So this states that from A to B, f of x dx is equal to from A to B f of t dt. Well, what does this mean? This means that we can change the variables whatever we want. See, in the case in the LHS we have x. I mean the function is with respect to x and you have integrated with respect to x. Where in second, in the RHS we have function with a independent variable as t, and we are integrated with respect to t. So we can change the variables as we want, but there will no change in the limit. See, limit is from A to B, here also A to B. So sometimes I also call it as change of variable property. Change of variable property. Well, how to prove this one? Well, the proof is very simple. Let's take the LHS, okay? Let me consider LHS. LHS, what is that? A to B f of x dx. Well, let's make a substitution. So what is substitution? Let me put x is equal to t. This is my substitution. And if I differentiate this one, so I'll be getting dx is equal to dt. And as you all know, my dear friends, in the integration, definite integral, if you make a substitution, accordingly we need to change the limits by using this relation. So see, if x is a, that is if x is lower limit, that is a, then what t will be? If I write a here, so t will be a. So this is our new lower limit. And if I take x as b, t will be obviously b. So see my dear friends, there will be no change in the limits. It will be as it is. Now let's rewrite this integral. Limits have not changed. So let me write a to b as it is. And f, instead of x, we can write t because that's our substitution. In the place of dx, we can write dt. So now we can see my dear friends, we started with LHS and what we got is RHS. So LHS is equal to RHS. So this is a property number 0, that is P naught, called as change of variable property. I can change the variable whatever I want, but the limits remains the same. For example, let's say I have a question like this. Let's say 0 to pi by 2 sin x dx is my question. Let's assume that. Okay, the same thing can be written as 0 to pi by 2 sin t into dt. No problem in that. We can do this one. So this is the property number 1. So please take down this one. Well, dear friends, the next property, that is P1, states that integral from a to b f of x dx is equal to negative of b to a f of x dx. What a change that you can observe? Well, the property says if I change the limits, if I shuffle the limit, I need to write minus sign. So generally I call this property as change of limits property. So whenever I change the limits, I need to write a negative sign. Okay, well, let's prove this one, my dear friends. So let's take LHS. So if I take LHS, this is from a to b f of x dx. Okay, and as we know that we have seen the fundamental property of fundamental theorem of integral calculus, wherein we wrote, let's say idana integration madadaga, let's say my answer will be f of x. Okay, and we get from a to b, and we can write this as f of b minus f of a. We all know this one, right? This is the basics of definite integral. Now see, my dear friends, let me take minus sign common here. So what I will be left with? I will be left with minus f of b plus f of a, or I can write this as f of a minus f of b. Yes or no? I have taken negative sign common. So now I can write this one as, see, whenever we have integral from a to b f of x dx, we will be writing upper limit minus lower limit. So this will be the upper limit minus lower limit. So now if I reverse it one, ನೋಡಿದ್ರೆ reverse ಆಗಿ ನಾನು ಈ ಸ್ಟೆಪ್ ಇಂದ ಈ ಸ್ಟೆಪ್ ಮಾಡಬೇಕಂದ್ರೆ what I'll do, this will be my upper limit and this will be my lower limit, and ಇದ್ರದ್ದು ಡೆರಿವೇಟಿವ್ ಬಂದ್ಬಿಟ್ಟು f of x dx ಅಂತ ಆಗುತ್ತೆ ಅಲ್ವಾ. ಅಂದ್ರೆ ರಿವರ್ಸ್ ಸ್ಟೆಪ್ ಮಾಡಿದೀನಿ. I reversed the process. ಇಲ್ಲಿ ಅದು ಥಿಯರಂ ಪ್ರಕಾರ ಮಾಡಿದ್ರೆ f of b minus f of a. ಸೊ ಇದನ್ನೇ ನಾನು f of b minus f of a is nothing but integral from a to b ಅಲ್ವಾ. ಸೊ ಇಲ್ಲಿ f of b minus f of a ಅಂತಿದೆ, but ಇಲ್ಲಿ f of a minus f of b. So I can write from b to a with negative sign. So now you can see, my dear friends, we got RHS. So I started with LHS and we got RHS, and that's the proof. So what you can see is this is the property number 2, change of limits, my dear friends. So please pause the video and note it. Well, dear students, the next property is something like this: P2, which is equal to from a to b f of x dx is equal to from a to c f of x dx, from c to b f of x dx. So what I have done is I have break the limit, that is a in the b ಇರೋ ಲಿಮಿಟ್ ಅನ್ನ ಬ್ರೇಕ್ ಮಾಡಿಬಿಟ್ಟು we have taken from a to c and c to b, something like this. For example, ನೋಡಿ, ಈಗ ಇಲ್ಲಿ 1 ಇದೆ ಅನ್ಕೊಳ್ಳಿ, ಇಲ್ಲಿ 3 ಇದೆ ಅನ್ಕೊಳ್ಳಿ. ಸೊ ನನಗೆ ಇಂಟಿಗ್ರಲ್ ಫ್ರಮ್ 1 to 3 ಇದೆ ಅಲ್ವಾ. ಸೊ ಇದನ್ನ ನಾನು ಈ ತರ ಬ್ರೇಕ್ ಮಾಡಬಹುದು, 1 to 2 ಪ್ಲಸ್ 2 to 3 ಅಂತ ನಾವು ಇದನ್ನ ಬ್ರೇಕ್ ಮಾಡಬಹುದು ಅನ್ನೋದನ್ನ ಹೇಳ್ಕೊಡುತ್ತೆ ದಿಸ್ ಪ್ರಾಪರ್ಟಿ. ಸೊ ವಿ ಕಾಲ್ ದಿಸ್ ಪ್ರಾಪರ್ಟಿ ಆಸ್ ಬ್ರೇಕಿಂಗ್ ದ ಲಿಮಿಟ್ಸ್ ಅಂತಾನು ಕೂಡ ನಾವು ಕರೀಬಹುದು. ಓಕೆನಾ? ವೆಲ್, ಸೊ ಲೆಟ್ಸ್ ಸಿ ಹೌ ಇಟ್ ಕ್ಯಾನ್ ಬಿ proved. So let me take the LHS, which is from a to b f of x dx. Alva? So by second fundamental theorem of integral calculus, we can write this as f of x from b to a, or we can write this as f of b minus f of a. We know this basics, isn't it? Well, now I can write this one as f of b minus f of a. Let me add and subtract f of c, my dear friends. I can do this one. It's an adjustment. Yes or no? Because I can cancel this term and this term. Yes or no? So now let me rearrange these terms, these 4 terms I'll rearrange, and I will write in this way, my dear friends. ಮೊದಲಿಗೆ ಏನು ಮಾಡ್ತೀನಿ, I'll write f of c then f of a ಅನ್ನ ಬರೀತೀನಿ, ಇವೆರಡನ್ನು ಕ್ಲಬ್ ಮಾಡ್ತೀನಿ. ಹಾಗೆ f of b ಮೈನಸ್ f of c ಅಂತ ಮಾಡ್ತೀನಿ. ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ತೀನಿ ಹೇಳಿ, ಇವೆರಡನ್ನ ಕ್ಲಬ್ ಮಾಡಿ ಫಸ್ಟ್ ಗೆ ಬರ್ತೀನಿ, ಇವೆರಡನ್ನ ಕ್ಲಬ್ ಮಾಡಿ ಕೊನೆಗೆ ಬರ್ತೀನಿ. ಯಾಕಂದ್ರೆ ನಾವು ಇಫ್ ಐ ರಿವರ್ಸ್ ದ ಪ್ರಾಸೆಸ್, ಈ ಪ್ರೊಸೆಸ್ ಅನ್ನ ರಿವರ್ಸ್ ಮಾಡಿಬಿಟ್ರೆ ಇದು ನೋಡಿ ಎಫ್ ಆಫ್ ಸಿ ಇಂದ ಎಫ್ ಆಫ್ ಎ ವರ್ಗು, ಅಂದ್ರೆ ಇದನ್ನ ರಿವರ್ಸ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ಹೇಳಿ, ಇದು ಮೇಲೆ ಬರಬೇಕು, this term should come here, so f of x dx. From these two terms I got the first integral, and from these two terms I'll be getting the next integral, that will be from b to c f of x dx. And check, this is what actually we were expecting alva. So nodi LHS ididdu a to b f of x dx ittu, and we got RHS. The only important thing in this one is this particular step. What I have done in that step, I have added and subtracted plus c. So this is the third property. Well, so let's summarize. These three are very very important properties, though these will not come for exam, but to derive or to prove the next properties we need to know these three properties carefully. So first one is change of variable property. Andre if you want to write x dx, you can write, or you can write t times t into dt kuda baribodu. Second one is what? Change of limits. If I change the limits, I need to change the sign also. And the third one is breaking the limit. I can break the limit whenever I want to. So these are the three properties. So please write down this one. Well, dear students, so the next property is something like this. Integral from a to b f of x dx is equal to a to b f of, see the function has changed now, adding the lower limit plus upper limit, adding the limits, subtracting from x will be the property. Well, let's prove this one. Okay, this is very important. Okay, my dear friends, this is important property because many times it's been asked in the exam. So let's take RHS. Let me start with RHS this time. Okay, so this is from a to b f of a plus b minus x dx. Okay, yeah. So now let me make a substitution. For the substitution, I'll write put a plus b minus x, this whole thing as, let me write as t. So I have substituted as t. Well, now let's differentiate. So a is constant 0, b is constant 0, minus as it is x will be dx which is equal to dt, or you can write dx is equal to minus dt. Well, we know this one, but since we are in definite integral, whenever I make substitution, correspondingly I need to change the limits also. So how to change the limits? By using this relation. So what I'll do, I have two limits, right? One is lower limit, upper limit. So if I take lower limit, what will happen? If I take upper limit, what will happen? Okay, so if I take lower limit x as a, what will be t? So substitute a here, plus a minus a cancel, I'll be left with b. If I take x as b here, plus b minus b get cancel, I'll get t is equal to a. So those are my new limits. So therefore this corresponding integral will become, limits have been changed now from b to a and f as it is, and this one we substituted it as t, and dx is minus dt, my dear friends. I hope you understood this substitution and everything. Yeah, wonderful. So the next step, what I'll do is, let me take this minus sign outside. So this will be from b to a f of t, then we'll be having dt. Now let me reverse the limits. Let me change the limits. So if I reverse the limits, what I'll be getting? I'll be getting minus sign, but since I already have minus sign, so minus into minus will be positive, isn't it? So this will be from a to b f of t and dt. So ಏನು ಮಾಡಿದೆ ನೋಡಿ, ಪ್ರಾಪರ್ಟಿ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಚೇಂಜ್ ಆಫ್ ಲಿಮಿಟ್ಸ್, ನೆಗೆಟಿವ್ ಆಫ್ ನೆಗೆಟಿವ್ ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ ಅಲ್ವಾ. ಸೊ now what I'll do is, I will replace the t with x because that is the property number 1. So I'll write this as a to b f of x and dx, which is nothing but LHS, I think. Yes or no? Yeah, that's nothing but LHS. So I have applied here one property and here also one property. So this is the very very important property. I hope it's clear for you. Alright. because on the basis of this one we have the next property which is similar to exactly same as this one. Okay, yeah, so please note it down. Well, dear students, so the next property is P4, which says that from 0 to a f of x dx is equal to from 0 to a f of a minus x. Actually, this property is exactly similar to the one we proved now, because in the previous property we had from a to b alva. So aವಾಗ ಏನು ಮಾಡಿದ್ವಿ ಹೇಳಿ, a plus b ಮಾಡಿದ್ವಿ. So a plus b ಮಾಡಿ minus x ಮಾಡಿದ್ವಿ ಅಲ್ವಾ. So ಈಗ in the place of like we have 0 and a, so if I add these two, 0 plus a will be a minus x. So ಇದು exactly ಅದೇ ತರ ಇದೆ. So we'll proceed with the same way. Okay, so let me start with RHS. So let me take RHS, and what is RHS? From 0 to a f of a minus x dx ಅಂತಿದೆ ಅಲ್ವಾ. ವೆರಿ ಗುಡ್. ಸೊ ಇವಾಗ ಏನು ಮಾಡೋಣ, ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡೋಣ. ಏನು, ಪುಟ್ a ಮೈನಸ್ ಎಕ್ಸ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಟಿ ಅಂತ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಮೈನಸ್ ಡಿ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು ಡಿ ಟಿ ಆಗುತ್ತೆ, ಅಥವಾ ಡಿ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು ಮೈನಸ್ ಡಿ ಟಿ ಅಂತ ಆಗುತ್ತೆ. ಸೊ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದಿನಲ್ವಾ, ಸೊ ಲಿಮಿಟ್ಸ್ ಕೂಡ ಚೇಂಜ್ ಮಾಡಬೇಕು. ಸೊ ಇಫ್ ಎಕ್ಸ್ ಈಸ್ ಎ, ದಟ್ ಇಸ್ ಲೋವರ್, ಸಾರಿ ಎ ಅಲ್ವಾ, 0 ಇದಲ್ವಾ ಲೋವರ್ ಲಿಮಿಟ್. ಸೊ ಲೋವರ್ ಲಿಮಿಟ್, ಆಮೇಲೆ ಇದು ಅಪ್ಪರ್ ಲಿಮಿಟ್. ಸೊ ಕರೆಸ್ಪಾಂಡಿಂಗ್ಲಿ ಟಿ ಏನಾಗುತ್ತೆ ನೋಡಿ. ಸೊ ಟಿ ವಿಲ್ ಬಿ, ಇಫ್ ಐ ಟೇಕ್ ಎಕ್ಸ್ ಆಸ್ 0, ಸೊ ಟಿ ವಿಲ್ ಬಿ ಎ. ಇಫ್ ಐ ಟೇಕ್ ಎ, ಟಿ ವಿಲ್ ಬಿ 0 ಅಲ್ವಾ. So this particular integral now reduces to limits have been changed, right? That will be from a to 0, f of this is nothing but t, and dx is nothing but minus dt alva. So now let me take minus sign common, that is outside. So I'll be getting from a to 0 f of t, then I'll be having dt. So let's change the limit. If I change the limit, I'll get one more minus sign. So minus into minus will become plus, isn't it? So this will be from 0 to a f of t, then I'll be having dt. So the last step, what should we do? Very good. We will replace t with x. So I'll be getting, this is from 0 to a f of x and dx, that is nothing but our LHS, isn't it? Well, my dear friends, this is a really important property, because most of the questions from the exercise will be based from this property. So when I solve the problems, that time will come to know how important this property is. Okay, so please note down this one. So dear friends, in today's session, what all we have learned? We have learned almost 6 properties, right? Not 6, 5 properties. So property number 1 is change of variable. Property number 2, change of limits. Property number 3, breaking the limits. Property number 4, summing the limits. You can call it as. Actually, they are not the names written in the textbook. I have made it. Okay. So fourth property in ಹೇಳಿ ಲಿಮಿಟ್ಸ್ ಅನ್ನ ಆಡ್ ಮಾಡಿಬಿಟ್ಟು ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡೋದು ಅಲ್ವಾ. ಸೊ ಅದು 4th 5th ಕೂಡ ಅದೇ ತರ ಇದೆ ಅಲ್ವಾ. ಸೊ ವಿ ಹ್ಯಾವ್ ಕವರ್ಡ್ those properties today, and in the next session we are going to see another 3, I think. Another 3 properties in the next session. So do practice this one, so that will be easy for us in the next session. So till then, take care and bye bye.